All right, happy Wednesday. We are going to be doing the Recognizing Reactions Lab. I'm certain you've got that open already. We're going to have to do this in two videos because the fourth part is going to take some time, and I'm not sure that I've got a 15-minute limit on the video time, and so I think the first three will probably take about 10 to 12 minutes to get through, and then that last one might take a little bit longer than 5 minutes. So, here's procedure for part one. Let's make some observations of sodium chloride, which is this substance right here, and silver nitrate, which is this substance right here, because here is our procedure. Observe and record the properties of sodium chloride and silver nitrate solutions in the data table below. And then I'm going to combine them together. So let's see things on a little bit bigger screen. Here's our sodium chloride. Wow, it looks like a clear liquid. And by the way, it's an aqueous solution. You see the AQ right there? AQ just means that there's salt dissolved in water. It's mostly water, and there is some salt that's dissolved in it. Same thing here with the silver nitrate. It's mostly water, and it has some solid silver nitrate dissolved in it. So there's another liquid. It looks fairly clear. It's got kind of a gray cast to it, and I think that's showing up fairly well on the video. So what I'm going to do is take a test tube, and I'm going to go behind the camera. Actually, why don't I just shift my chair so you can see everything that's going on, and rather than holding it, I'm going to put the test tube right there. So I'm going to put in some sodium chloride. Okay, now I'm going to add some silver nitrate. It says to add a few drops. I'm going to add a little bit more because on the video it's not going to show up all that well. So I'm going to add a little bit more than what we are supposed to add. So the key thing that you're watching right now is watch the liquid right there. I'm about to add some silver nitrate, except the cap is stuck. All right, now I got it off. Okay, so I've got a dropper, and I'm going to just drop some silver nitrate in. There's the first drop. Ooh, that's kind of cool. And let's do a couple more drops. Wow, the camera looks sort of like it's a slow motion camera. There's our third drop. Looks like white cloudy stuff is forming. And it's sitting on top of it's sitting way up high in the test tube. And each time I drop another drop, you can see that more of that whitish substance is being produced. And I think I'll put in about one more drop. And then the procedure says let it sit around for a while. And I'm going to let it sit around. There's my last drop. I'm going to let it sit around, and I'm actually going to show you what happens after the third part. So let's get this out of the way and bring this in, do an extreme close-up. And extreme close-ups do not work that well. So there is our test tube, and you can see some of that white stuff is dropping to the bottom of the test tube. That's actually really cool. I could watch this for another 5 minutes. So yeah, so the white stuff originally started off at the top, and you can see that a lot of it is settling on the bottom of the test tube. And it looks a little bit milky, but if it's sort of a liquid, it would just sort of mix together, but this stuff is really dropping to the bottom fairly quickly. So anyways, I'm going to set this test tube aside, and we will have a look at it a little bit later. What you need to do right now is make observations in this data table. So properties, this column right here, that's what it originally was. So we had a couple clear liquids, and the silver nitrate may have had a little gray cast to it. And then observation of reaction. So all the things that I was describing, we've got that white milky substance. It seems to be settling to the bottom. And just in terms of a temperature change or anything else, I don't think the temperature has changed any. And we'll have a look at it a little bit later, and I think there might be some things that you're going to add to the observation of reaction. So there's the end of part 1. I'm going to pause the video and set up part 2. All right, let's begin part 2 now. I've got the hydrochloric acid. It's in this bottle. I have a strip of magnesium. It's this metal right here. So what we need to do is make observations of the properties and then record them in the data table, which is right here. So we're going to look at the hydrochloric acid. We'll look at the magnesium separately. You'll write down the properties, and then I will get them to react. So first of all, I'm going to take some hydrochloric acid and put it in this little itty-bitty tiny beaker. And why am I using the dropper bottle when I can just simply pour it out? And that should be sufficient hydrochloric acid. So I'm going to bring this close to the screen and make things a little bit bigger so that we can actually see things. And hydrochloric acid doesn't look like any other, looks just pretty much like water. It's just a clear liquid. But it does have some acid in it. I guarantee you, it's got acid in it. And here is the strip of magnesium. It's just it's a metal. It's kind of a thin, it's sort of like a ribbon. In fact, that's what this is called. It's a magnesium ribbon. And it is pretty thin on that side, pretty thin there. And it is solid. It's fairly flexible. And I'm just going to take it and I'm going to put it into the hydrochloric acid. But I'm thinking that I would like the hydrochloric acid. I'd like a little bit more in the beaker. All right, so now let's combine them together. I wish this camera would focus better. There we go. I'm just checking on focus, whether we can get it to go any better. All right, here goes the magnesium into the hydrochloric acid. And first of all, hopefully you can hear that. Lots of fizzing happening. You can see that there's a whole bunch of cloudiness. You can see the fizzing happening. And there is gases that look like they're being released that are bubbling out through the top. You can see all sorts of bubbling happening all around the surface of the magnesium. And if you are carefully observing, you can see some vapors that are leaving the top of the beaker. So it looks like some gas is being produced. Well, yeah, there has to be gas being produced because there's all sorts of bubbling that's happening around the magnesium strip. I'm trying, let's see if I can turn it like this without spilling. Nope, that's not going to help. Let's get a bird's eye view of what's going on in there. And of course the strip goes right against the beaker wall. So the magnesium strip is right against the beaker wall. You can see some bubbling and some fizzing. I know that that camera is not capturing things as well as I'd like it to be capturing things. But now I've also noticed that, oh my goodness, the magnesium is gone. There's no magnesium, there's no bubbling left. So when you look at the side of this, the magnesium has completely dissolved. And another thing I'd like to observe, or at least I can observe it, that the temperature is really warm. So the beaker, the liquid, the acid, has warmed up in temperature. So there is the conclusion of part 2. So what you need to do right now is get back in here. All the things I was describing about the reaction, we have a temperature change, the magnesium dissolved. There was lots of fizzing, lots of bubbling. So it looked like a gas was being produced. So those are the things you should be recording in there. And I'm going to pause and set up number 3. All right, here we go with part 3. First, we're going to observe the properties of phenol red, water, and hydrochloric acid, and you're going to record them in your data table right here under properties. So let's go to the big screen and have a look at stuff. Quite exciting on water. Oh my goodness, it's a clear liquid. Ooh. Hydrochloric acid is nearly as exciting. Again, we have a clear liquid. And phenol red. There it is right there in a bottle. It kind of looks like Kool-Aid, but it ain't Kool-Aid. Don't consider this to be Kool-Aid. It is an indicator. It is a chemical which will change colors depending on how acidic a solution is. So phenol red is called an indicator. And so basically, we have the lab part of this is just taking phenol red and putting some phenol red in the acid, and then also into the water and seeing if we get any changes. So you've got your properties listed. Now let's see what happens when we put phenol red in water first of all. That would be this test tube right here. So I'm opening up the bottle of phenol red. I've got some drops to add, and so I think I'll add a couple drops. And oh my, phenol red. And I know that that's not very colorful. Because I have so much, I'm adding probably more phenol red than what you really need to add. But there we go. Phenol red looks like it's still reddish. If that was not exciting, I don't know what is exciting. Okay, now let's look at what happens when we add it to hydrochloric acid. So that would be this test tube right here. So now phenol red in an acid. Observe. Here we go. Nice. It's a different color. Look at that. It's going to be orangish. And if we're lucky, it might even be more yellow than orange. But I think that we're going to get just the orange color. I'm going to get a white background. It's better to look at colors when you have a white background. So in our white background, there we go. So there is actually, I'm going to add a little more phenol red to the acid. Just a couple more drops. And really, all it's doing, the color doesn't really change, it just gets more intense. All right, so here is the original color of phenol red. And then there's phenol red with water. There's phenol red with the acid. And so we get a color change when we put it in the acid. All right, there's part 3 of 4 parts completed. You're going to have to tune in to a different video for the part 4. So I will see you in the part 4 video.